Mofi, we spend so much time talking about the brain of the agent, which model to use and how to prompt it well, how to give it memory. But we rarely ask the most basic question: where does this agent actually live?
So for an agent, we have a number of different options, obviously. We have Vertex AI Engine, where we can have a fully managed experience. We also have Cloud Run, where you can bring your container and run your agent. But we also have options like GKE, where you have a full options of all the different choices of running both of your microservices, running your own models, as well as your agents.
Yeah, I think it's a very important question to discuss because if you choose the wrong home for your agent, you can really hit the wall on things like security or cost or even using a runtime that doesn't scale like you promised your bosses. So, welcome everyone to the Agent Factory. Today, we're going to figure out how to take the agents we built out of the lab and into the real world. I'm Shir Meir Lador.
I'm Mofi, a long time listener, first time caller. I am super excited today to bring in a special guest to tell you all about all the things we're doing in the world of GKE to make running agents a better place. So I would like to welcome at this point Brandon Royal to the call.
Hey, thanks everybody. I appreciate the opportunity to be here. Brandon Royal, I'm a product manager on the GK team. Like you, Mofi, first time, long time. So excited to be here.
Awesome. Thank you so much for joining us, Brandon. And thank you also, Mofi, for joining us to host the show for the first time. I'm super excited to have you both today. And by the end of this episode, hopefully, we will be able to answer the questions of how to select your agent runtimes. When should you choose the complexity of Kubernetes over the ease of serverless, as you mentioned, Mofi? And is GKE actually becoming the ultimate operating system for AI agents? I'm curious to hear about that. And also, we would hear a little bit about the Sandbox challenge and how can we solve it with GKE. Okay, so the first question that comes to mind for me, and I'm sure for a lot of our developer audience, is why should we choose GKE as your agent runtime when you have things like serverless options, like Cloud Run that spins up and spins down instances for you on demand, or fully managed agent hosting solutions like Agent Engine? What is the benefit that GKE brings to developers?
Yeah, it's a great question. And I'm sure, a lot of the audience out there is asking a similar question. Right? This Kubernetes thing has been around for a long time. There's a lot of great, managed serverless offerings for running agents. Why should I even consider something like Kubernetes? Well, I want to first start with the fact that both serverless compute and Kubernetes these are not new, right? And of course, when you think about deploying any sort of non-AI agent, any normal application, you need to think about sort of similar kind of considerations. How do you have a trade-off essentially between simplicity, convenience, and sort of extensibility, flexibility, and scale? And so this really applies equally well to agents. As soon as you're thinking about, going beyond the first handful of agents and need high scale scenario where you have, hundreds or even thousands of agents that you need to sort of manage all together and, build better governance around and have more flexibility and extensibility. Right. This is where Kubernetes is really going to shine. And that's where you're going to start to see that sort of tipping of the balance from, where it just makes more sense or maybe the sort of flexibility and extensibility is ultimately going to outweigh the convenience that you'll get out of a serverless platform.
I see. So it seems like GK is mainly for like the super users of agents where you have like hundreds of agents in production and you need a lot of control and compute power for those.
Yeah, and there's another simple fact too, which is that because Kubernetes has been around for so long, it's pretty well established within a lot of enterprises. And so it's very likely if you're deploying an agent today and you're in an enterprise environment, you have a Kubernetes cluster somewhere. So if you're having a hard time sort of bringing in the latest and greatest serverless platform for agents, you might be able to just look in your own backyard and find a Kubernetes environment like GKE that you can use out of the box.
Yeah, actually, I think Mofi and I participated in a customer engagement like that, where they were already using GKE and then they deployed all their agents on GKE. So definitely, that's a good another
Makes
scenario.
it a lot easier for sure.
And the other thing also to think about is agents is one part of the equation. Obviously, you also need the model. So for most of our users, for most of the users building agents, I think some sort of model like Gemini 3, which recently came out, would be a great option to start with. But there are industries like government or healthcare or maybe financials where they wouldn't be able to grab off-the-shelf managed model like this. So they would have to run their own models, right? So with GKE or Kubernetes in general, you now have the options to host your own models and then have your agents talk to those models as well. So for those kind of use cases, you kind of can keep both your models and agents in the same environment, right? And the other thing, kind of Brandon a little bit hinted towards, is that GK is already, or Kubernetes is already a well-established pattern for building microservices, right? At the end of the day, and I'm going to probably anger some of our viewers a little bit, agents are just applications, right? So agents are another set of microservices applications that you're going to have in your ecosystem of applications. So if you already have environments that are good at running microservices really well, chances are it will be good at running your agents really well as well. So GK is already established as a good place to run your microservices. Now you can have a bunch of agents running in the same environment, more microservices too, that GK can already is really good at handling.
Yeah. So basically, you're saying in addition to running your agent on GKE, you can also host your model on GKE, and then they both can talk to each other on the same environment. That makes a lot.
Yeah, with GK, you have choices of all GPU offering on Google Cloud into as well as TPUs. So again, the latest Gemini models and all the Gemini models prior was trained in TPU and hosted on TPU. So a lot of our customers are now using TPUs to train and host their models. So yeah, again, you can train your models. If you don't have to train, you can fine tune models. You can host fine tune models on GKE and have your agents then talk to those models that are running already in the same cluster.
Yeah, I love it that GK provides all those possibilities, both inference and fine tuning and agent hosting. That's awesome. And I know in previous episodes we talked about ADK by Google, the Agent Development Kit. How does that fit into the GKE picture? Can we develop our agents on ADK and then deploy them on GKE? Is that even possible?
Absolutely, yeah. I mean, ADK is an open source framework that anybody could use. Again, as long as it can put the application in a container, GK will be then able to run it. And this is not just like for ADK. Any type of agentic framework you're using, Crew AI, LangChain, Llama Index, like whatever you're using, right? As long as you can put them in a container, we can definitely run that on GKE. And I think it would be fun for our viewers to see a demo of that happening, right? Like running an ADK agent on GKE. So if that is all right with the both of you, I'm going to quickly jump in and
Yeah,
show a quick demo of how that happens.
that would be awesome. What kind of agent are you showing us, Mofi?
I'm going to probably build a fairly straightforward agent, but before I do anything, I'm going to open up our documentation on how to do that. So if you actually open up the ADK docs, again, Agent Development Kit ADK is something we have been investing quite a lot in. So that's what I'm going to show. But again, everything we're showing here, all the learning of deploying an agent, fairly easily carries over to other frameworks like Crew AI or LangChain. But in the documentation, if you're seeing in the screen right now for the viewers that are watching, we are in the documentation. We actually have all three targets of deploying ADK. So Agent Engine, Cloud Run, and GKE documentation available. If I open up the GKE documentation, you would see that we have two options. One is manual deployment using gcloud and kube control, where you create a cluster, you create your everybody's favorite YAML files to define how your agent should be, write your code, package the application in Docker file using a Docker file, and then push that and run it. You also have, for more simplistic agents that doesn't have a lot of different resources requirement, you could just choose the automated deployment using the ADK deploy GK command. Very similar command to ADK deploy agent engine or ADK deploy cloud run. So if you have a ADK code, you can just run this command from that repo, and it's gonna, whatever GK cluster that is connected to your current context, we're gonna deploy that onto that cluster. Uh, because the agent we're building here is a little bit more involved, and I will show why that is the case, we're going to choose the manual deployment option. And this gives you the full control about exactly what are the libraries that should be in your agent, what are the different resources that should be, what connection points you want to create to rest of the Google Cloud infrastructure. All of that is available because, again, we can control the entire flow of how that happens. So here I have an ADK agent definition, right? So if this is the code you would potentially get if you ran ADK create like a new agent. So you're seeing this extra function here. Don't worry about it right now. This is what you're going to see in a second. This is a tool definition that I have created that we're going to see and how to use it. So only thing that is different in this agent versus what you would have out of the box with ADK is just this. I have this new tool defined, right? So once I have this defined, I can now run this ADK with ADK web, which would set up basically local host serving of this agent, which I can then open in my browser. If I go to localhost 8000, and I'll select my agent, which is code exec agent. And this is just your usual ADK agent. I can just send hi. It will respond back with something. Again, this is just connected with Gemini 2.5 Flash. So it knows general information, things like what is the capital of France, right? This is, again, nobody's going to lose their mind over like LLMs knowing information. This is fine. To deploy this agent now, we have a few different options. Obviously, I could try ADK, deploy GKE, which will just try to create a Docker file, deploy that to my Kubernetes cluster. But for most of our users, when you're trying to deploy something on GKE, you don't just like randomly want ADK to decide what to deploy. You want to have the full control over exactly what and how you deploy it. So for doing that, we can define a Docker file, which is, again, installing all the dependency, as well as setting up this UV current main.app file, which is this function that is also provided in our documentation. In this, we're taking the most default options, but you could also define any type of extra paths, health checks, other things you can. But again, this is already as is provided from our documentation. So once all of that is available, we can then build our Docker image and then deploy this to Kubernetes. So in this case, we are defining this agent. I built this image already in example here. And I have this YAML file. Once again, this is as is given from our documentation. And once everything is ready, I can just do kube control get pods. You would see my agent is running. I deployed that half an hour ago before the call just started. And then I can do kube control get service. And you will see that I have this ADK agent that is deployed and have an external IP. So I can go there and do the same exact thing. So I can, if I copy this URL and open this up in my browser, and you see my agent is already selected, and I can ask the same questions, like it'll respond back. I can ask the same question, what is the capital of France? And potentially get the same answer back. So this is now live on the internet. I have a load balancer IP that anybody on the internet can go. By the time you're watching this, that IP probably will be taken down. So you'll not have this agent available to you. But to deploy this, again, the flow of it is very similar to what you're already used to. You just take your application, put it in a container, set up some YAML, it's running.
So just to clarify for those like me who are more used to serverless options. So in serverless, we usually define the agent code and create the Docker file. So here, the extra steps you basically needed to take is adding that main PY file, right?
Yeah, so the main.py file and the Kubernetes YAML, because again, Kubernetes
Yeah.
talks the language of YAML.
And what exactly specified in the Kubernetes YAML?
Yeah, let's take a look at that Kubernetes.yaml file one more time. So first things first, we define a deployment. So in Kubernetes, the concept, the lowest deployment value is a deployment, which counts how many replicas. So in this case, we have one replica of your agent running. So if you want to say this agent is big, everybody wants to know the capital of France. So thousands of people are trying to talk to this agent. Instead of one replica, I can run multiple copies of the application, right? The next thing is we're defining this image, which we build and pushed ourselves with a Docker file. And then we define some resource and limits, right? We say each copy of the application should have 128 megabytes of memory and about half a gigabyte of RAM. And so in my cluster, the cluster I'm using is a GKE autopilot cluster. Not to go into too much details, Autopilot would give you the closest thing on GKE that is closer to serverless. You only pay for the application that is currently running. So if you're used to that model of, oh, my application is running, I pay for it, Autopilot gives you that as well, with all the control of Kubernetes as well. So it's kind of best of both worlds. You get all the APIs of Kubernetes to do everything, but also the pay per pod model that you're used to in Cloud Run.
Yeah, I like that autopilot option. Sounds good, especially for serverless folks like ours. So this is great. You get the best of both. Okay, so now we have our agent running on GKE. And let's look at what this agent does. I see that the name is a code execution agent. So where does this code execute exactly? Is it running locally? What are the risks of running code locally, and how are you solving those here?
Yeah, so I think for a lot of this audience, you're probably all very familiar with code execution. I would imagine actually I don't have to explain why allowing an agent to do things like code execution is really valuable. I'm sure many of you are familiar with Claude Code or Gemini CLI, and you're using that as a part of your sort of everyday development life. It's really one of the most popular kind of use cases for agents. But when we think about deploying sort of agents for code execution in our local development environments, that's quite a bit different than actually deploying it out into a server. It's a single, development workstation running, say, Cloud Code or Gemini CLI. It's single tenant, and even though the LLM generated code might be untrusted, it's at least my environment, right? As soon as we take the power of code execution and we start to deploy it to a server side environment where we might have multiple users, multiple tenants, now the risk gets escalated quite a bit. So now we need to treat that as an untrusted code, but then we also need to sort of make some assumptions about potential bad actors, doing things on different tenants and ensuring that our data and our users are safe and secure in each one of those tenants. So that's I think where things get a little bit scary, and really where we start to introduce the concept of a sandbox.
So, for listeners who are not security experts, what is a sandbox in this context?
Yeah, sure. So, Sandbox is again one of those technologies that's actually been around for quite some time, and really the idea of a sandbox is quite simple, right? We're simply just doing kernel level isolation. There's lots of different ways that sandbox is actually an incredibly overloaded term, but really from our perspective, we take security and isolation quite seriously. So our definition of sandbox is a minimum of kernel isolation and network isolation, so that a process that's running code cannot access other users' data or other users' information. It is truly isolated. Just like you imagine a physical sandbox, right? We can allow kids or whatever to play and be sort of safe within the boundary. We want to allow sort of full flexibility and freedom, but we want to create a very tight boundary between those spaces for security reasons.
Okay, so why do agents specifically need this?
Yeah. So when you think about what agents are actually doing on a regular basis, they are, we're asking an LLM to generate code. And depending on the use case, if it's a code generation use case like for software development, that it might actually be generating an application, or it actually might be generating a full application and then sending that to a hosted environment. We need to assume that all of that code is really untrusted and always needs to be completely isolated. Now, the other challenge, sort of interesting dimension of applying agents to sandboxing and code execution, is that the level of scale is, orders of magnitude higher than what we've seen with previous sandboxing scenarios, where even a single agent is going to be writing lots and lots and lots of iterations of code. Those each need to be sandboxed potentially in their own environment, and then you have lots of agents that are doing this together. So really the scale of AI agents is really what's making this sort of an interesting new infrastructure problem for us to solve.
Yeah. So I'm convinced. How do we build those high fences for agents in Kubernetes?
Yeah. So, from our perspective, the sort of underlying primitives of sandboxing, as like I said, has been around, right? We've had micro VMs and gvisor and a bunch of other like very battle tested kernel isolation tools that have been around, but they've really only been accessible to infrastructure engineers. So only if you're sort of the lowest level, infrastructure or security engineer do you actually interface with these kernel isolation technologies? And we said to ourselves, well, we want to make this more accessible to the sort of the average developer or the average operator who is sort of building and deploying agents at scale. And so we really wanted to sort of create essentially a new API within Kubernetes to allow you to deploy sort of sandboxes much more easily, and to allow you to deploy thousands and thousands of sandboxes as needed for your particular agent, and do it quite easily. So that's actually why we've introduced a new API directly within Kubernetes, or we just announced it actually just a couple of weeks ago, called Agent Sandbox, and so it aims to do exactly that.
Nice. That sounds impressive. So, Mofi, I know you brought a demo of this. Can you show us this in action?
Yeah, so let's take a look. So, as Brendan mentioned, this is a brand new API that is available that you can install. It's a CRD. CRD stands for Custom Resource Definition. And again, not to go into too much details about what they do, but it is a way to extend your Kubernetes capability without basically changing the underlying software. You're adding more, you almost like extension to your Kubernetes. So in this case, we're adding this extension called Agent Sandbox. And I'll go into my terminal and I'll just open up a new window here. So if I were to do my cluster, look at my cluster and look at resources in this cluster, and I will see that in my cluster, I have few extra like a resource types defined in this cluster called Sandbox, Sandbox claims, Sandbox templates, and Sandbox warm pools. And the ones we're going to take a look at for the most part is the Sandbox, Sandbox claim, and Sandbox template. So sandbox template, it's by definition is what you define as what each of the sandbox should be. So as a platform team, you can define that when my users want to do any type of code execution, I want to give them a sandbox environment with predefined and preloaded Python or whatever library you want to, right? So instead of your code executing in a like untrusted environment, now you're locking in exactly the version of library that you want, exactly the environment you want to give them. So when again, as Brendan mentioned, when you're doing it thousands and thousands of time across your entire company, you want to make sure that every execution of that code is happening in a trusted environment as well as in a repeatable environment, right? So if the code were to be just like generated and run across any machine, then you're back to the problem of it works on my machine, right? So we can solve that with templates. We can create this template. Sandbox claim is from your application or the agent, then asks for one of those templates to be available, one of those sandboxes to be available. So you make a claim for one of those. And once you do that, GKE or the Kubernetes distribution will then create this one of the sandbox claim, which will spin up on Kubernetes cluster as a pod. And then you can go and execute your code. You have some Python library at this point exist to do that. So back in our code here, and now we can look at the code execution tool that we already had seen a little bit, but I can now take a look at a little bit more detail. We can see that I have this sandbox client, which are important from this agentic sandbox. Again, this library is available as part of the agent sandbox GitHub repo as part of Kubernetes 6. We can put that in our documentation if you want to go learn more. So we're importing this sandbox client, and we're setting up a couple of things. One of them is Python runtime template. That is the template we're defining, and the namespace. In this case, we're going to default namespace and trying to target the Python runtime template. In my cluster, if I were to look for the sandbox templates, I could do keep control get sandbox templates. You would see that I have this Python runtime template. And the definition of this is defined here in runtime template. And I have this image, which will be every time I spin up a copy of those template, that's the image is going to be using. This image is a fairly straightforward. It sets up a server where you can send a request to, and it's a Python environment set up in there. Okay, so when I want to execute my code, I want to send Python code to this sandbox and get the result back. Back in my agent, we defined this tool where we said, first, again, if you're familiar with ADK tools, in the top of the ADK tool, the doc string, we define how this tool and what this tool does. So basically just says execute code in a secure Python environment. And then arguments are code. So my LLM, when it calls this tool, will have to send this code string, and it gets back response from the tool itself. So whatever code I get, I write that into my sandbox as script to run.py. and then I sandbox run. So it just executes arbitrary commands, in this case, Python commands to Python script to run. And whenever a response comes back, we just take the standard out from my result. And that's what comes back to my LLM, right? So let's take a look at that in action. All right. So here we ask the question to the agent, which is what is the 56th prime number? And this is something you don't actually want your LLMs to randomly guess, right? This is something you can calculate. We can get the response back exactly by calculating the prime numbers. So I asked this question, and then you see that from ADK UI, there was a tool call of code exec tool, and the response came back with 56 prime number is 263.
So your agent is basically programmed to or instructed to write the code to calculate this on the fly and then execute that code to answer the question.
Absolutely. So if you take a look at, and ADK is awesome in giving you all the details on how the tools are being called. If I open up the tool call that happened, you can see that my function call generated some code on the fly, and this code string is Python code, again, valid Python code. And then it is using an algorithm to calculate if a number is prime or not. And then it is doing that until a range of 56. So we are getting, basically, once this response comes back, we are getting the 56th prime number. And this is, again, very simple example, but you can actually scale this to any type of code execution scenario where your users are doing things with your agents, and the agents then need to execute code to get the response. So we can get that execution happen. But while this is happening, I'm going to kick off another example, but I want to show you what happens in the behind the scene as well. So
Yeah, so as Mofi's going through that, I think it's important to emphasize that, this example is a pretty simple one, right? And very similar to what we were talking about before, where you have, a serverless environment versus more of a, Kubernetes, more flexible based environment. The same thing goes with Sandbox and code execution. There's, Gemini-based code execution tools that you can use out of the box. You can, of course, use things like Vertex code execution, and there's other SaaS platforms that also provide code execution tools. I think the difference is here is just really the flexibility and being able to go beyond, just the simple example that Mofi is showing here. Let's say, instead of Python, you want to use Golang, or let's say you want to, render a very specific application, maybe with your own code base, or maybe you want to take an application, render it, and then you want to move it over into a serving environment, right? That's where the flexibility, I think, of Kubernetes really comes in, and where this tool really starts to shine. Yeah, so as Mofi was talking about, essentially each time an execution happens, a new sandbox is created. So there's a new sandbox claim that creates a new sandbox environment. It's essentially executed in that isolated environment, and then it's essentially turned down. So each one is completely ephemeral and isolated.
Awesome. But what I'm wondering about is that if we spin a new pod for every single task, that may take some time, right? What about the latency of all this?
yeah, and that is $1 million question. I think the answer for that is pod snapshotting.
Oh, what is pod snapshotting?
So right now, every time, and in general in Kubernetes, every time you want to spin up a new pod, what we do is we either go download the container image from a registry and then give it resources and allocate the resource and spin up this pod and put it in running state. But for something like sandboxes, our running state is pretty well known, and we know exactly what our running state should be looking like. So what if we could basically take a snapshot of our running state, and every time we want that container to start, we can just start from that running state instead of going through the full motion of downloading the container, setting up some environment variables, all that other things we do every time. Because again, a sandbox environment is fairly well known. We know what the state should be, and we can just do that, like we do that every time we do this, right? For this example, every time we're executing code, we're starting from, basically we're starting from scratch, but we could start from a running Python environment. So that would be what pod snapshotting basically is.
Yeah, I think that you absolutely nailed it, right? There's lots of pre-processing that might happen. And again, let's think about some of these more complex kind of scenarios, right? Let's say you have an entire code base that you're doing code execution on. You don't want to have to download and load all that information every single time you want to do code execution. You want to start from a well-known state. And so every single time you do a code execution, or run a set of LLM generated commands, you always want to start from that state, and that drastically is going to lower your startup latency.
I really like the idea of a pod snapshotting and how it prevents that kind of cold start. Is there a way to demo that now to our audience?
Yes, pod snapshotting, we can just do a quick demo. Again, by the time you're watching this, pod snapshotting should already be in public preview. So everything we're seeing here, you should be able to replicate on your own GKE clusters. So I have a GKE cluster set up with pod snapshotting. Once again, pod snapshotting, the mechanisms of it are installed onto this cluster as a custom resource definition or CID. So if I were to do a kube control API resources, and grep on the word snapshot, I should see that I have a few extra definitions that are defined here. Ignore the volume ones because we're not using that for this, but pod snapshot is what we care about. And we have 4 different ones. We have pod snapshot policies, pod snapshot manual triggers, and pod snapshot storage configs. For the example here, we also are going to create another sandbox using a sandbox claim. So in this cluster, I have a few sandbox claim defined. So if I do kube control get sandbox templates, and I'm going to grab it from all the namespaces. And you see I have this one template defined here called Python runtime template in the namespace sandbox test. So if I were to do kube control get sandbox claim dash and sandbox test, you'll see right now I have no claims created, right? And what this template is, I can take a quick look at this sandbox template. So the template we're defining here is a pretty simple one, which is instead of setting up a proper Python environment, it just sets up a Python run, which does import time. And while true, every second prints out the time, right? So again, once you create a sandbox claim using this template, that is going to start from time 0. And for every second, it's going to print 1, 2, 3, 4, all of that. So let's create a sandbox claim using this template. In this case, I'm just to save myself from typing a lot of things, I'm just going to make a copy of this here and apply that one. So which is going to create a sandbox claim in the namespace. Again, the namespace is a variable that is set already, which should deploy that to sandbox test namespace. So if I do this, we should see that a new sandbox example got created. So if I were to do kube control get PO dash and sandbox test, I should see a new pod that just got spin up about 14 seconds ago. So if I were to take a look at the logs of this particular pod, I could do kube control logs dash and sandbox test and name of this particular pod. You would see that it is printing the number starting from 0. It's at this point gone up to 28 because 28 seconds has passed. So the concept of pod snapshotting is that I can take a snapshot of this pod with all the things that is currently in the memory, CPU, including IO and networks, everything. We can take a snapshot, store it in Google Cloud Storage, and use it later. So what I'm going to do, I'm going to once again grab this snapshot code. So what I'm doing is we're creating a manual trigger. What a manual trigger is that when I run this, when I deploy this Kubernetes object, it takes a snapshot that in that moment. And in this, you can see that I have a target pod of Python sandbox example. So that is the name of my pod here. So I'm just basically taking a snapshot of that pod at this moment. So once I do that, you will see that my snapshot was taken at that point. I can see the status of that snapshot. Get pod snapshot in the namespace, which is sandbox test. And you would see that I have this pod snapshot here. The other thing I also can see is kube control get pod snapshot manual trigger in the namespace. And you would see that my manual trigger was completed. What that basically means is the moment the manual trigger completed, I stored all the state of that particular pod and stored that in Google Cloud Storage. Now, if I were to go back and create another copy of this sandbox claim, which I can do with this one. Now we're naming it Python sandbox from snapshot and giving it the same exact template. What would happen is the snapshot controller would see that I have a snapshot with this exact template. So when I create a new copy of this pod, instead of going through the motion of creating from scratch, I can just create it from the moment the snapshot was taken. Now, again, Shir, at this point, you might be thinking, Mofi is saying a lot of things, but I don't really believe that happened. So hopefully I can convert and prove to you this actually is a snapshot and not from scratch. If you remember, the copy that runs from scratch starts the count from 0, right? So if I took the snapshot properly, the new pod that got created, which is Python sandbox from snapshot, should start from a number higher than 0. So if I want to do kube control logs dash, oh, nope, let's try it again. Kube control logs dash n sandbox test and copy, paste our name of our pod. If I do this, and if everything worked properly, we see the count actually starts from the number 89.
Oh,
Because, again, at the time we took the snapshot, on the pod, the number was already at 89. Just to make sure that the snapshotting is getting us like some faster deployment time, we're going to do that one more time. So that's going to happen very quickly. So don't blink or you'll miss it. So I'm going to just do it. Once the object gets created, we should see within a second, it's already in running state.
oh, wow.
Because again, we didn't actually have to set up anything. We just downloaded the stuff from GCS and set all the values in CPU and memory and IO, and it's just in running state right away.
How long would it usually take, like, without the snapshotting?
So if you had to go download your image or set up any kind of environment variable in the beginning, it can take anywhere from like 1 second to up to like 10, 20 seconds, depending on what you're trying to do. But with snapshotting, we consistently have seen time drop anywhere from 3.5 to 7 times than regular time. Brandon, you have any specific more number?
Yeah, absolutely. So it depends on how long your application takes to start. And so there's a couple of big scenarios here. Like one, exactly as Mofi was talking about, if you have something that's processing some data or loading something into cache or pulling some data down, or whatever it happens to be, you're going to cut that down to single digit seconds. The other scenario, which the sort of counting number, right? It's kind of a silly example here that Mofi was showing, but it illustrates a really good point, right? You can basically take something that's already running, and then you can stop that as well. So it's not just for reduced latency, which is absolutely a big portion here of the value. It's also for doing things like hey, I don't want to run this anymore. Like let's say I'm waiting for a human to respond for a human in a loop kind of scenario, or my LM generated code is hosting something that's effectively idle, and I want to spin that down and then spin that back up. So the startup latency is important, but also the ability to sort of arbitrarily pause my pod whenever I want, and then not consume any of that resources and restart it just like it was running before is super powerful.
Awesome. So it also adds some layer of efficiency here, right?
Yeah, absolutely. Absolutely. And again, if you're doing this for a handful of agents, you can do this with serverless, like no problem. And serverless is going to perform really well. But when you're doing this with, thousands of agents or tens of thousands of agents, and you're really thinking about the level of scale, right, these types of infrastructure efficiencies, really play a huge role. One thing I'll also note too, since you were talking about startup latency, pod snapshots is one really powerful new feature that we're introducing to help with that. There's also some other sort of nice features that are built directly into the Agent Sandbox API. Mofi mentioned it really quickly earlier. For those viewers, you might have caught it. There's also an ability to sort of create a warm pool of sandboxes. So in addition to using snapshots to sort of snapshot and restore, you can also say, hey, I just want a pool of Python environments to be sort of ready and waiting to go. And we can get that latency down significantly. We've seen upwards of 90% reduction in startup latency by using those sorts of techniques. So different tools for different scenarios, but end of the day, our objective, our sort of hope is that you'll see a lot of value in having this sort of sandbox based API that you can use for managing the lifecycle of your sandboxes.
And the other thing I also want to mention here, the pod snapshotting specifically, right? So we looked at pod snapshotting in the context of sandbox environment, but pod snapshotting, as Brandon kind of mentioned, is that works for pretty much anything you want to take a snapshot and run it again, right? Or run it very quickly. For example, scaling your LLM workload, inference workload. You can snapshot a running inference workload and then say, I want to make a second copy of this. And instead of having to go to like Hugging Face and download the model again, or set up the model weights back onto the GPU, you could do that all very quickly with snapshots. So this is something that is, I think, going to improve the quality of life in Kubernetes workload for pretty much the entire stack, wherever you are. This, I think, I can see this helping workloads that has like a long startup time, like JVM based applications can benefit from this. So again, it really helps the sandbox environment stuff in Kubernetes, but pod snapshotting, it's much broader than just like sandbox environments.
Nice. Well, I'm super excited that we were able to showcase this new feature here. GKE is not just hosting our agents, right? It's also protecting them and making them faster. Brandon and Mofi, this has been incredibly insightful. Thank you so much for joining us today to the Agent Factory and helping me and the audience understand when GKE is the right choice for our agents' home.
My pleasure. Thanks for having us.
Anytime.
Yeah, and thank you everyone for tuning into the Agent Factory. Brandon and Mofi, are you ready to power it down with us?
Yes.
I'm ready. Powering down.
Down.